Hi everybody. I'm so glad you decided to watch this video today because it's probably the most important video of the chapter. And I'm sorry if it's a little longer than usual, but it's going to be really important to understand everything else because we're going to be talking about prisms today. And we kind of have to learn all the new stuff. Now, yesterday you should have learned that a prism is made up of two congruent and parallel base shapes. And so, do you have like a colored pencil or a highlighter or something? I want us to just color in the base shapes on this prism. There should be two of them. They should be parallel to one another. So we should be coloring in these two hexagons. Now this is just an example. They don't have to be hexagons, but they do have to be congruent and parallel. So two bases, and the other sides are these rectangles, right? So here are the formulas of the day. I want you to write down surface area is 2b plus capital P lowercase h. And so the capitals and lowercases mean something special in this chapter. Volume will be capital B times lowercase h. So let's talk about what those letters stand for. Capital B is area of the base shape. If you were in class, I would ask you every day, what does B stand for? Because we tend to say base, but I would make you start again. What does B stand for? Area of the base shape. And so in this example, what are the base shapes? Those two hexagons. So what I want you to do is use that same color. Do you see why the number 2 is there? Why would we have to take 2 times the area of the base shape? Because there are 2 of them. And on this one, we're going to take the area of the base shape. So we're just color coding this because the area of the bases is this part of the formula. And so what would this part of the formula be? And I want you to write this down too. This part of the formula is the area of all of these rectangles around the sides. We call those the lateral faces. Lateral faces. And it's perimeter times height because those are rectangles. And I'll show you in a little bit more detail where that comes from. So those are the formulas for today. I think the best way to explain the surface area formula is to show you the unwrapped net of a prism. And so this unwrapped thing right here is called a net. And you could cut it out and fold it up and it would make this shape. And you see those two congruent parallel triangles? Those are the base shapes, right? And so on this net, those would be right here and right here. So then what do all of these rectangles in the middle stand for? Those are going to be the lateral faces. So most people don't have a hard time understanding why the 2B happens because we have two base shapes, but let me talk to you about the PH. Do you see that we could find the area of each rectangle separately? And if we add all of those areas together, we would have the total surface of that prism. But there's actually a shortcut, and that is finding the whole rectangle area all together. Now, do you guys know where this 3 shows up on the actual prism over here? That 3 is going to be the distance from that top orange triangle base to the bottom orange triangle base. So they call that the height of the prism. Okay? So that's from base to base is always going to be the height. All right. See how when we wrap this 4 and this 5 and this 3, that matches up with our bases, right? The 4 and the 5 and the 3. It'll wrap nice and tightly around there. Do you guys know what the 3 plus the 4 plus the 5 represents? It represents the perimeter of those base triangles. So that's what the P stands for, is the perimeter of the base shape. That's why it's a capital P, because it's talking about like a separate formula that you have to calculate. So here's why the formula works. This entire piece along the bottom is the perimeter, and this 3 right here is the height. And so if I take base times height, I get the area of the rectangle, which is the area of all 3 lateral faces. Now, volume is talking about how much can be held inside of our prism. I like to think of this as cubes of ice. So how many cubes of ice could I fit into my prism? Kind of the way to think about this is we could just measure how many cubes it would take to fill up that bottom layer, and then we could just layer layer, 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 all the way up to the top. So if you think about it, remember that base shape is that triangle, right? If you could find the area of the triangle, 1/2 base times height, the area of the base shape tells us how many cubes of water will cover just the bottom layer of this, right? So in this case, it would be 1/2 times 4 times 3. And so that's a total of 6. Well, it's square units when we think of the area, square area. It's 6 total cubes that would fit on this bottom layer. So it takes 6 cubes of ice to fill up the bottom layer. That's B. And then we would need another 6 for the next layer and another 6 for the next layer. So that's 3 levels of 6 ice cubes. So do you see why the height being 3 tells us how many levels of ice cubes to stack in there? Now our main goal with these formulas is to actually calculate how much surface area and how much volume these prisms hold. So the first thing I want to show you is this common mistake that people make. When they look at this prism, they don't realize that it's sort of tipped over. It's not standing up on its base anymore. Because remember, a prism always has 2 bases that are congruent to each other. Well, a lot of people tend to think that this bottom rectangle on the table and this top rectangle on the top side would be the bases, but those wouldn't be congruent. So those are not the base shapes. What 2 shapes are congruent and parallel on this solid? And it's a little tricky because it's knocked over. This front trapezoid is one base, and the other base is hidden. It's in the back. This base on the back is my other trapezoid. And then you can see that all of these rectangles along the sides would make up the lateral faces. And this big rectangle on the bottom is actually a lateral face. So that's probably the most confusing part, is when these things tip over onto their sides, being able to tell that those base shapes have to be the trapezoids. All right, welcome to the main event. Here I've got all of the measurements that I'm going to need to calculate the surface area and volume. And we've already done the hard part, which is figuring out what shape the base is. So we are going to use, I'm going to use blue for base here. So what we're going to do first is we're going to find what capital B equals and what capital P equals. And then the H is lowercase because that's not the height of the base shape, that's the height of the prism. And so that's why the capitals and lowercases are important to pay attention to. Let's do capital B first. What does it stand for? The area of the base shape. In this case, the base shape is a trapezoid, so I'm going to take 1/2 times base 1 plus base 2 times height. And the height is from base to base, which is 8.06. The area formulas are on the back of your packet if you need to look at those. And I get 96.72, and that's an area, so that's in square inches. What does P stand for? P stands for the perimeter of the base shape. What shape is the base? A trapezoid. How many sides does a trapezoid have? 4 sides, so we're going to add those 4 sides together. And that comes out to 42, and since that's a perimeter, that's 42 inches. Now the height of the prism, this is kind of the tough part because we used 8.06 for the height, but that was the height of the trapezoid. This H stands for the height of the prism. And my favorite way, if you want to write this down, this could be helpful. From base to base. How far is it from trapezoid to trapezoid on this? That's what the 7 inches is. And the reason this one's tricky is because this is laying down on its back. If it sat up on those trapezoid bases, the 7 would be top to bottom. But if you think of it from base to base, that 7 inches is going to be the height of our prism. If you can figure out those, the rest of it's so simple. So here we go. Surface area. 2 areas of the base shape plus those lateral faces would be the perimeter times the height. We know that the perimeter of the base shape was 42 and the height of the prism is 7. Yeah? So all of that comes out to 487.44. And what's the label on that? What kind of inches? It's a surface area, so square inches. And all that represents is how many little square stickers it would take to cover the whole surface of this prism. Now the volume, first we find how much it would take to fill up that bottom layer. One trapezoidal layer is going to take 96.72 cubes of ice. How many layers would it take to get from bottom to top, or from base to base? 7 layers. And that comes out to 677.04. And the label on volume, do you remember what we were filling this with? We're filling it with cubes. So I call those cubic inches. Now, you shouldn't really compare these two numbers because they're measuring different things. This one's talking about how many squares to cover the thing, and this is talking about how many cubes to fill the thing. I've got one more nice example for you. When you look at this shape, the first thing you should do is try to identify which shape are the bases. Can you find the two congruent faces that are also parallel to each other? This one's tricky because there's a lot of congruent faces, but the only two that are parallel to each other are the top, and we can't see it, but there's a bottom one here, right? And so those are our base shapes this time. Where would the height go? The height always goes from base to base. So this would be the height of the prism. The height of the base shape might be something different, but that's the height of the prism. All right, let's do this with some numbers. We already talked about how the base shapes are pentagons. These are actually regular pentagons. Do you remember how to find the area of a base shape when it's a regular pentagon? The area, and again, those formulas are on, it's at page 16 in your packet, 1/2 apothem times perimeter. So to find the area of one of those pentagons, we would take 1/2. The apothem is that 2.1 right there. And the perimeter would be 3 plus 3 plus 3 plus 3 plus 3. Is that 15? I guess we could write that one down right away too. We just found the perimeter of the base shape is 15 inches, right? All right, so this one comes out to 15.75, and that's the area of the base shape, so that's square inches. It would take almost 16 squares to cover each of those bases. And then the height, remember, the lowercase h stands for the height of the actual prism from base shape to base shape, and that's labeled as 2.5. Now on your assignment, I'm making you write down the b, the p, and the h every time, because if you get the surface area wrong, that's the first thing I'm going to look at, is to see if you had those right. So surface area, 2 of those base shape areas plus the perimeter times the height of the prism. 2 times 15.75 is 31.5. I'm doing these separately this time. The 15 times 2.5 is 37.5. I did them separately just to point out something. The base shapes, these two shapes together, make up 31.5 of the square inches, and these rectangles around the sides make up 37.5 of the surface area. So there's actually more area contained in these side lateral faces than the two bases. If I add those together, then I'll have the total surface area, which is 69 square inches. Now, on your worksheet, I might ask you a tricky question like, what if this didn't have a top on it? Then what would you have to subtract, or what would you have to leave off? You'd have to leave off one of those base shapes, or you could just start at the beginning by leaving off that 2. So you'd only have one base shape plus those lateral faces. So just watch the question so you'll know if I'm asking for the lateral area or the area of the bases. That might switch up once in a while. The volume's pretty straightforward. The volume is just going to be the area of that base shape. How many cubes of ice would fit on the bottom times how many layers of ice to fill the whole thing up. And that comes out to 15 sorry, I didn't type that in before. 39, oh, color coding, 39.375. And that's how many cubic inches it would take to fill up the inside of this.